In this part of physics, we're going to talk about 3 points briefly. First point, we're going to talk about Compton effect and Heisenberg uncertainty principle, and we're going to talk about what? De Broglie wave or de Broglie wavelength. And the second point, we're going to talk about the spectrum of hydrogen atom, or the series of the spectrum of hydrogen atom. And the third point, we're going to talk about laser. Okay, this is now the first point. We're going to talk about these 3 main ideas, which is Compton effect and Heisenberg's uncertainty principle and de Broglie wave. Okay, as we studied before, we studied that light is photons. Based on the definition of Einstein, that light is photons. And these photons, they have energy. And this energy is given by the formula energy equals H, which is Planck's constant times the frequency. And this idea, it proved that light is a particle, or light are particles, or they behave like particles. And also we studied before that Young's experiment proved that light behaves like waves. So that means we have some experiments that prove that light behaves like waves, and some experiments that prove that light behaves like particles. And there are conclusions that light behaves like both. Light and electrons, in general, they behave like waves, and they behave also like what? Like particles. So one of the experiments, as I said, it proved that light is more or behaves like particles is Einstein experiments, and one of the main experiments that proved light behaves like waves was what? Young's experiment. Okay, based on that idea now, based on this idea that light can be particles and can be what? Waves, we have here the first one here, which is Compton effect. What is Compton effect? Compton effect, just the main idea of it, they said when light is moving as photon and it collides with a particle, for example, this particle is electron, what would happen for this photon of light when it collides on electron? As we know, the light contains a specific energy, which is as a result of the specific frequency. So now the light now will give some of its energy into what? Into that electron, sense of the collision. The electron then will move in one direction because it gained more energy. So it gains some of the energy of the photon, while the other photon now, when it loses this photon now that is coming from the light, when after collided with the electron, it will move in another direction with less energy, with less what energy, since it lost some of the energy for the electron. So this shift now of the energy of the photon, because this is now, it was energy, then here it was what? Different number of energy, right? So this shift now of the energy of the photon is called what? Compton effect. Compton effect. And this, as a result, we said when the light, or when the photon of light collides with a particle. Okay, we go to the next point now, which is Heisenberg uncertainty principle, or it calls just what? Heisenberg's principle. What he said? He said just that it's impossible. It's impossible. This is what is the uncertainty principle. He said it's impossible for us to understand or to get or to identify or to determine the place or the position of a particle like electron, and also to understand or to calculate its momentum at the same time. So again, what is this statement? He said it's impossible to determine the amount of the momentum of a particle and its position at the same time. Why? Because now if we deal, for example, if we deal with the electron as a particle, if we deal with it as a particle, when we go now to study or to see where the position or the location of this particle, we need to use light or use to do something, an experiment, to know where is the place of that electron. In this time now, when you use light and you use experiment to see where the electron, in this case, you will not find the electron, or the electron will change its place or will change its velocity. So that means in this case now, it's impossible. Till now, he said that statement 100 years ago. Until now, it's still impossible for us to understand or to get the velocity, which is related to the momentum of an object and its position at the same time. So this was what his principle. Okay, what about the Broglie wave? The Broglie wave, he said just that any moving object, for example, a car is moving object. We are like moving object. Anything that is moving, it has wavelength. It has wavelength. And he said that this wavelength then, it can be calculated from this formula, which is what? Planck's constant over the mass of the object times the velocity. So he created, or he said that any moving object has a wavelength, and this wavelength is calculated from that. And we use this formula to calculate the wavelength of electron, the wavelength of a car, or the wavelength of any moving object. But now, if you use it now to find the wavelength of big things, macro things like cars, like trucks, in this case, the mass will be big, and then the wavelength will be very small. And since the wavelength of big things that we see them, like cars, like human people, like any things that we can see them by our eyes, these things, when we find their wavelength, we're going to find that this wavelength is very small, so we cannot see it. But in real, based on the Broglie principle, he means what? They have wavelength. Okay, and we have a fourth idea, which is for Bohr. He said the laws of electromagnets cannot be applied or are not applied inside the atom. So these ones now, all these ideas that we studied now are in modern physics. Modern physics now are different from the classical physics that are related, like Newton laws and other ones. And in general, the classical laws not always applied with the modern physics. So these ones now are new theories or new principles and experiments that are related to modern physics that mainly focus on light and quantum theories. Okay, we'll go now to the second point. The second point now is related to the series of hydrogen atoms. Okay, as we studied before, and as we know, any atom, it consists of a nucleus, and around it there are shells. And as we know, for hydrogen, it has an electron here. For the hydrogen, this atom of hydrogen has an electron here. And this electron now, if we give it a photon of light, that means we give it energy. If we give it energy that is quantized, this electron will jump or will move to higher energy levels. So it will go from here, n equals 1, maybe it will go to n equals 2, or to n equals 3, or to n equals 4, if you continue, or n equals 5. So that means this electron will move to higher energy levels. Then when this electron moves, for example, it moved to the third shell. So it moved to a higher energy level due to absorption of energy from the photon. Now this movement to higher energy levels, it will not be permanent there. It's just temporary. That means the electron will move back to its what? Will move back to its original energy level. When it moves back to its energy level, it will emit wavelengths. It will emit energy as wavelength. That means it will emit frequency. And this frequency or this energy that it will be emitted due to the electron when it's coming back from higher energy levels to lower energy levels, these ones are called the spectrum of hydrogen atom, or the series spectrum of hydrogen atoms. So these ones now, these spectrums are different based on the electron it moved back to which level. So if this here and this case, when the hydrogen, as we see, it moved back to the first level, to the first shell here. In this case, it produced frequencies that are called ultraviolet rays. Ultraviolet rays. So that means when the electron of a hydrogen atom moved from any higher energy level into the first energy level, it will produce ultraviolet rays, and these ones called are what? As Lyman series. So Lyman series, as you see, this is now the first level, and this is now n equals 1, and this is n equals 2, and this is n equals 3. So in this case now, when the electron is coming back from any higher energy level, whether from the third or from the fourth level or fifth level, from any higher level, when it comes back to the first level or the first energy level here, it will produce ultraviolet rays, and this is called what? Lyman series. Okay, what about when the electron moves back into just the second level, from any higher level into the second level? So in this case now, this level here, if we draw it here, it's not clear. When you draw this level here now, as you see, when the series are coming back to the second energy level, it will produce visible light. So this is now visible light, and also this visible light is called what? Balmer series. Okay, what about now if the electron is moving from higher energy level into the third energy level, from any higher level? That means either from the fourth or from the fifth or the sixth, from any higher level into the third energy level. In this case, it will produce infrared, and this one called is what? Paschen series. Okay, third point, we'll talk about what? Laser. What is laser? So what is laser? Laser is a word, is a short word that is like a short abbreviation for light amplification by simulated imaging of radiation. So in general, what does that mean? Here now we have the sun, and the sun, when it gives us light, it gives us the light in different wavelengths, in different frequencies. So the light, as you see, it moves this way. One wavelength is high, like it goes to 1 meter, like radio waves, and one goes into nanometers, or much smaller. So in this case, different wavelengths, different frequencies. So this is the nature of the light that we receive from the sun. Okay, what about if it is what we have? Electrical bulb here. It's the same. When it gives light, usually it gives what? The light in different phases and in different frequencies. Usually. Okay, what about now the light that it comes from what? From laser. The light that it comes from laser, by the way, and usually they move in the same phase, you see? So they have the same crest and the same top as well. So that means they have the same phase and also the same frequency. That means in general same speed. So they are also coherent. That means, and they usually have one color because they have the same frequency, and they are directed and usually have higher energy. So this light now can move for long distance and can be used with many things in our lives. One of them is to test the straightness of tunnels, or to use it to cut many things, or to use it in medical applications. So in many things we use laser, but laser mainly now, it is just waves that have same frequency, they have same color, they move in the same direction, and they have usually higher energy level. Higher energy based on what we are studying, but now we have also lasers that have low energy. levels. That's for this part, so you can go to solve the question related in the quiz.